hello viewers, this is Turning Point once again. So we want to look into the previous class. We did plane mensuration, and if you recall very well, we talked about the formulas that will guide us through. And one of the areas we discussed was circle. Talk about circle. We discussed the formulas. Then we also talk about the square, and we did mention rectangle, and we ended with the triangle. And triangle, remember I talked about the hero's formula, don't forget that. Talk about the area 1, recall. Area 1, I said half base times height. Talk about area 2, I mentioned half AB sine theta. And then I mentioned area 3, talking about the hero's formula, bracket, hero's formula, which is square root of s into s minus a into s minus b into s minus c. And I said that a, b, and c, they are the sides of the triangle. And then your s is the average of the three sides, a plus b plus c divided by 2. So with this introduction, we'll go into the formulas for other plane shapes. And what are the plane shapes we are dealing with today? We'll be talking about, apart from these on the board, we are going to look into trapezium. We'll consider parallelogram. We'll consider rhombus. And then we may likely end with kites. So kites, will end with kites and see of the formulas. Like I said in the previous class, we are not going to calculation. We are here to give you the formulas introduction. So let's look at trapezium. Well, for you not to, just to remind you of the shape, let's just look at this diagram. Don't forget the trapezium. The property of trapezium. It has two parallel sides. This is short parallel side, which normally term as A. This is longer parallel side. We have called it the B. And then from this place up down is your height, or you can put it here. And this is your angle 90, you can put it here. I also have angle here, theta, in some special cases. Okay, so this trapezium, we're looking at the area where you have half into bracket the summation, the addition of the parallel sides multiplied by the height. Okay, and take note that sometimes in some questions they won't give you the height, they'll give you angle here. So you are going to use formula like what do you have now? Half into a plus b, and we'll take sine theta. So with that you can solve. So then we'll look at parallelogram. Let's look at parallelogram shortly. Before I even go to parallelogram, take note there are some topics or some questions in mensuration where parallelogram has relationship with a triangle. See, we'll come up with that not in this class. So parallelogram sometimes share the same base with the triangle, and there are associated properties. So when a parallelogram is sharing the same base with the triangle, you must understand something, that the area of the parallelogram, look at it now. If you have a parallelogram, let me just quickly show you that. So you understand something there. This is a parallelogram. And then you have a triangle coming in here. Okay? Now, the area of this triangle, take note of this. The area of this triangle here, this is the parallelogram. Let me put parallelogram A, B, C, D. So we have triangle ADC. We have parallelogram. A, B, C, D. There's something about this. I'm trying to digress it to show you this, so that when I come up in next class, you will understand what I'm saying. So that the area of this triangle, is equal to half the area of that parallelogram. Okay. So understand this. Now, what's the formula you will need in solving parallelogram? What's the area of parallelogram? Area of parallelogram, please take this down, very important. Area of parallelogram. So area will give us what? Half simple, half base times height. So we'll apply these simple formulas when we're solving. Then when we advance into other topics, other aspects in this plane mensuration, I'm going to deal with this information I just gave you now. So, but let's look at rhombus. Rhombus is almost like a parallelogram, but only that all sides are equal. I see rhombus as a square that is slant, while I see parallelogram as a rectangle that is slant. So let's look at this. This is rhombus. Mind you, we are here for formulas. I take rhombus and just put all sides equal. So this side is equal to this side. They are all equal. Okay? So now one formula you want to know, what is the area of a parallelogram? Area of parallelogram, you can take this formula. Area of parallelogram is the product of the diagonal. Product of diagonal divided by 2. You can use this formula when you are solving parallelogram. Then we'll come to kites. Quickly. Let's look at the formula of solving kites. Not every student in secondary school, secondary level know the area of the kites. They just shy over it. It's a great area. But let us draw the kite and see something here. One part you must know about the kite is that the kite has only one line of symmetry. You can only divide it into 2 equal parts going down from here to this side. So looking at the kite very well, you will understand that the kite is a combination of 2 isosceles triangles. What I say is this side and this side are equal. Let me use one stroke. This side and this side is equal. This side is equal to this side. That's one part you must understand. Not only that, the angle here and here they are equal. What you have here, you also have here, are equal. Then not only that, from this side, from this end to this end is equal. From here to here is equal. Now, let's take triangle A, B, C. The first triangle, the triangle BCD. So triangle ABC and triangle BCD come together to form the kite. So how do you get the area of a kite? But let me just write on the board so you can see. Area of a kite is y into h1 plus h2. How do you get this formula? Follow me. Go back to the area of a triangle. You said that area of a triangle is half base times height. So let's go with triangle ABC. From triangle ABC, you discover that I have half base times height. So let's take from this first height now as h1. Then from here up this place is h2. That's height of the small triangle and height of the big triangle. Okay, half base times height. What's the base? Let's consider the base as since from here to this side is equal. That's to say from this middle point here, let's call it say y to here will be y also. So it's equal. So from here to here, y plus y give you 2y. So half base. The base now becomes what? From here to here, that's 2y. So 2y, y plus y, that's 2y. Multiplied by the height h1. When you add, what do you get? You have half 2y h1. So this 2 cancel this 2. What do you have left? You have y h1. Then if you consider triangle BCD, so from triangle BCD, what do you see? You see half, same thing, half base. What's the base now? The same base, they share the same base. Half base, that's 2y times height, that's h2. Then you add, you have 1 over 2, 2y h2. So one cancel this one, you have y h2. So I said that the kite is a combination of 2 isosceles triangles. So let's just combine. So first triangle is what? The area is what? Half h1. Then second one is what? Half h2. For those who have done factorization in your GSS class, you know that y is common factor, you bring it out to half h1 plus h2. So this is how we come about the area of kites. So this is the introduction of plane mensuration. We are not done. We are coming back to look at critical questions, that borders around the WAEC exams, the JAM exams, and the post-UME exams. So this is an introduction to this topic. The topic is very, very deep. So I will stop here, then we'll meet in our next class to look at real questions, because many students, they shy away from questions. When they miss question exam, you just see mensuration, they just dodge it. When they see anything like structure, they dodge it. So don't dodge it. We're going to break it down to the grassroots. I'll stop here for now. Thank you.